We want to find this small angle right here. So in order to do that, we would need a right triangle. However, it's not part of a right triangle. However, we can find the measurement of this big yellow angle. To find the measurement of that one, we would say that the tangent of that angle is equal to the opposite of 8 divided by the adjacent of 10. The tangent of that angle equals that. The angle itself then would be the tangent inverse of 8 over 10. So that would be that whole big yellow angle. And we can do that again because the yellow is part of a right triangle. Next, we could find the measurement of this smaller turquoise angle because it's also part of a right triangle. The tangent of this angle is 4 over 10. So the tangent of this is equal to 4 over 10. That means you could take the tangent inverse of that angle, tangent inverse of 4 over 10, and that will give you that little turquoise angle. So we can get the turquoise, we can get this whole big yellow angle, and in order to find the one that we want, we're going to take the bigger yellow one minus that turquoise one, and then what's left over is the marked angle. So we're going to take tangent inverse of 8 over 10 minus the tangent inverse of 4 over 10. And that gives us approximately 16.9 degrees. Now, some things that might seem like they make sense but don't actually work would be combining these tangents together. Since this says tangent inverse of 8 over 10 minus tangent inverse of 4 over 10, maybe you're thinking you can subtract those. 8 over 10 minus 4 over 10 would be 4 over 10, but that doesn't work. This does not equal tangent inverse of 4 over 10. Another thing you can't do is just take this entire yellow angle and divide it by 2. These two little angles are not equal to each other, so we can't just divide this inside by 2 to come up with the angle that we want. In a case like this, in order to find this angle that's not part of a right triangle, we had to subtract, take the big overlapping one minus that little one to get to the angle that we actually want. Next one, we want to find the sum of those two measured angles. So in order to find the sum of these two angles, we're going to do it in parts. First of all, looking at this angle that has the 1 mark on it. Relative to this angle, 25 is the adjacent, 30 is the hypotenuse. So we could say that the cosine, because it's adjacent and hypotenuse, the cosine of that angle is 25 over 30. So the angle itself is the cosine inverse of 25 over 30. And so you could take the cosine inverse of 25 over 30 on your calculator. That comes out to about 33.6 degrees. And it's not exactly that. The calculator has a lot of other decimal points in there, 33.557 and so forth. We want to keep the answer exact as long as we can. So we're going to store this in the calculator. If you get STO, then alpha A, we can store it as letter A in our calculator. And I'm going to make a note on my work saying that this is being stored as alpha A. Next, we're going to try to find the other angle, which I'll call alpha B. To do that one, we're going to find the measurement of this entire yellow angle. And in that triangle, 25 is the adjacent, 50 is the hypotenuse. So this whole big yellow angle is the cosine inverse of 25 over 50. We're going to subtract away from that, though, this gray angle. That gray angle is a part of another right triangle. 25 is the adjacent, 40 is the hypotenuse. So to find this gray angle, it would be the cosine inverse of 25 over 40. And if we took the yellow angle minus the gray angle, that'll give us the angle that has the double marking on it. And that angle comes out to about 8.7 degrees. And we'll store this one as another letter, store it as alpha B. And wouldn't necessarily have to store values. We could have entered this all in one step, but it's good to have the skills of knowing how to store values in there, because we'll get to problems eventually where you'll have 5, 6, 7, maybe even more than 10 different variables you have to store as you're going through the problem. So at this point, we know A, we know B, we want to know the sum of those. So on your calculator, all you have to do is alpha A plus alpha B. And it's coming out as approximately 42.2 degrees. Now, this is a case where if you look at what the rounded values were, we had A was about 33.6, B was about 8.7. If you add those values together, you would have gotten 42.3 instead of 42.2. Because this was rounded up by quite a bit, and this was also rounded up, which would have made our final answer rounded up more than it should have been. But if we just do the stored value of alpha A plus the stored value of alpha B together, then the sum of those two angles is approximately 42.2 degrees. So the next set, the directions say to find the exact value. When you see exact in the directions, that means no decimal approximations. We want probably fractions, and then radicals in simplest radical form. So if I went to my calculator and plugged in cosine of 30, it might give me some decimal like 0.87. That's not what we're looking for. We're looking for the exact value as a fraction. So we're going to actually draw this out. Cosine to me means, okay, it's trig, so I'm dealing with a right triangle. 30 degrees is one of the acute angles. So here's the 30-degree angle. And this isn't just a right triangle that has a 30-degree angle in it. It's one of the special right triangles. It's actually a 30, 60, 90 triangle. And there are ratios we know between the sides already. The key in this one is the short side. I could call the short length x. I could call it 37 if I wanted to. I think the best value to choose would probably be just 1. And since this is the key to all the other ones, I can find the length of the other two sides. The short leg is 1. The hypotenuse would be double that, or 2. And also, the long leg would be root 3 times longer than this. So this leg is root 3. Now, to find the cosine of 30, cosine is adjacent over hypotenuse. So from the 30-degree angle, adjacent is root 3. Hypotenuse is 2. Cosine of 30 as an exact value is root 3 over 2. Sine of 30 is opposite over hypotenuse. That would be 1/2. And tangent of 30 is opposite over adjacent. That's 1 over root 3. But if you rationalize that, it becomes root 3 over 3. Now for the other column, cosine of 60. Cosine of 60 is the adjacent from 60 divided by the hypotenuse, 1/2. And it's no coincidence that the sine of 30 and the cosine of 60 are the same. Sine of 60 should be equal to the cosine of 30. That makes it root 3 over 2. If you wanted to verify that from the 60 degrees, opposite of root 3 divided by hypotenuse of 2 does give us that. And then the tangent of 60 is the reciprocal of the tangent of 30. Or I can come over here, take the opposite divided by that adjacent, and it's root 3 over 1 or root 3. These two values are, in fact, opposites or reciprocals of each other. Might not look like it in this form, but initially for the tangent of 30, we had this. We rationalized it to get to that answer, and you can see maybe a little more clearly that these two are reciprocals of each other. One more thing we can do with this one to check it, if you went to your calculators and typed in cosine of 30 degrees, you would get a decimal. If you took the square root of 3 and divided it by 2, you get that exact same decimal. That's one way you can verify that these exact values are correct. Sine of theta is equal to 3x, so draw a right triangle, call this angle theta. The opposite over the hypotenuse is 3x over 1. But then when I get to cosine of theta, it says it's equal to 5x over 2. Well, this hypotenuse can't have a length of 1 and also have a length of 2. So I'm going to back up a little bit and say, all right, cosine of theta is 5x over 2. Let's make this equal to 2. But since the sine ratio is supposed to be equal to 3x, that means in order to keep that ratio, this length has to be 6x. So the sine of theta is 6x over 2, which does simplify down to 3x. So here is our triangle that's accurate to that given information. The first thing we're asked to find then is the tangent of 90 minus theta. Well, if this angle is theta, then the other acute angle would be 90 minus theta since they are complements. The tangent of this angle is the angle, or the side opposite divided by adjacent. So 5x over 6x simplifies to 5/6. The other thing we're asked to find is the measurement of angle theta. So if I go back to theta, I know that the tangent of theta is equal to 6 over 5. So if we took the tangent inverse of that, then the angle itself, theta, is equal to the tangent inverse of 6 over 5, and we can use our calculator to evaluate that. And the angle itself comes out to about 50.2 degrees. So there's 3 triangles in this diagram. We can use trig in this triangle on the left to find the length of y. From the 47-degree angle, y is opposite, 13 is hypotenuse. So the sine of 47 degrees is equal to y over 13. Multiply both sides by 13. And that's the value for y. You can put it into your calculator and then store it. So 13 times the sine of 47 is about 9.51. But I'll store that in the calculator as variable y. I'll make a note of that that is being called y. And now I'll use that for the triangle on the right. In this triangle, from the 50-degree angle, x is the opposite, y is the adjacent. So then we can say that the tangent of 50 degrees is equal to the opposite of x divided by the adjacent of y. Multiply both sides by y, and we have the value for x. Now, if I wanted to get a good exact answer, I could plug this y back in kind of as a substitution. 13 times the sine of 47 times the tangent of 50 is equal to x. So there is a nice exact answer. Or I have this programmed into the calculator and stored as alpha y. So you can take alpha y times the tangent of 50 to get the length of that x, and x is approximately 11.33. At this point, we don't have the formula to solve for theta using any trig, but what we can do is draw in this altitude, and because it was an isosceles triangle, it's also a median, a perpendicular bisector, and an angle bisector. It's everything. And that did create 2 right triangles, and we're going to focus on the one that's on the left. In that triangle, from the angle theta, it's actually now theta over 2 because we split it in half. 4 is the opposite, 12 is the hypotenuse. So the sine of this angle is equal to 4 over 12. So there's an equation we can use to set up. Now if you take the sine inverse of both sides, then theta over 2 is equal to the sine inverse of 4 over 12. Multiply both sides by 2, and theta is 2 times the sine inverse of, instead of 4 over 12, we can call that 1/3. So there is a good exact answer. You can plug it into your calculator just like that to have the answer. Now imagine most people would probably say the tangent or the sine of this angle is 4 over 12. So if I took the sine inverse of 4 over 12, I'll get an angle. That angle is about 19.47. You could store that if you wanted to, or just multiply it by 2 to come up with the angle. And the angle is 38.942444127. A lot of decimals in there, but we're only rounding to the nearest tenth because it's an angle. So about 38.9 degrees for angle theta in the original triangle.